Welcome, everybody, to today's episode of Incubator Weekly. We've got Matt again. How's it going, Matt?
Good. How are you?
Good. We're here for part 4 of the decoding platform Rust to JavaScript effort. And let me just take a moment to go into Discord and say that we're live now. If anybody has questions about what we're doing, why we're working on this, why I think it's so important, please come in, ask your questions. We'll post the question. We'll do our best to answer that. But for now, I'll go ahead and I forgot to get my screen share started because you're going to be doing most of the screen sharing, but I do want to share a couple things. So let me get that going here for a second. Okay. Infinite thing there. Let's see.
This is an example of the blockchain.
This isn't, yeah, I shared the wrong, let me stop sharing that one. I shared the wrong window. It's hard to grab the right one sometimes. While I'm doing this, why don't you give a brief explanation of what you're working on, and then I'll jump in with this after that.
Sure. Yeah. So I think the thing that I just finished about an hour ago, actually, is full round trip compatibility for the document contract create transition, where I wrote a little bit of Rust code using the standard platform SDK, dumping out a data contract. This is a dummy data contract that's not necessarily supposed to mean anything, but it has a lot of the contents filled out. So then we create the contract. And
sorry, I wasn't sharing your screen just yet. Let me do that.
Well, you were just a moment ago.
No, I jumped onto my screen real quick, but it wasn't yours. Here we go. Oh, I probably was, but I was sharing the wrong one accidentally. Why is it sharing my screen still? Technical difficulties here. No. It's because Discord has a new scene feature, or not Discord, but StreamYard has a new feature that it's trying to. Let me stop mine and start yours.
Oh, see, now I see it on the StreamYard live.
Oh, you do? You see yours on the screen, StreamYard?
I do.
I think they've got a bug. I think they've got a bug in their software because I don't see it.
Weird.
I don't see
it. Who is the real?
Let's check the audience. Anybody with us? I see we have some viewers. So if you're a viewer, let us know if you can see Matt Peterson's screen, because I do not see it when I usually do. And I see that they have a new beta screens feature that they have put in here, but I think they've got a bug because I, as the presenter, don't see the screen that you're saying that you see.
That's very strange.
Yep. Let me switch back to this view. You see that the view has changed, right?
Yep.
And now I'm going to switch back to presentation layout. Now it shows up for me as well. So why don't you go ahead? This wasn't showing for me before I did this. They've got a bug. Anyway, go ahead. Software's hard.
Software is hard. All right, so I have a public key. This is just a random public key, and the private key is in here as well. So we created a state transition, and we dump a whole bunch of byte representations of these just for ease of testing. And so I have this code printing out a bunch of the messages, and then I copied and pasted them into JavaScript. And we test a couple of things. One, that we can actually decode and encode them correctly and get the same thing back. that we get the signable bytes as well. That's like a cut down version of the message without the signature in it that we then sign and then tack the signature back on. So we got to make sure that the signable bytes are the same in order to sign it correctly. And then this is a bit of a mess because like I said, I just literally finished this an hour ago. So I was kind of just taking apart the way that we're supposed to do the signing and recreating it. And there's some things that we have to do to set the identifier to this strange thing that we do to make sure that the ID is like unique with the nonce and the owner ID who created it and stuff like that. Then we hash the message and then we sign it with the private key, and then we put the signature in to the contract, and then we pack it up and encode it, and then we check that we got exactly the same thing as the one that came from REST. So this is the signed transition, and we check that we get it exactly the same thing from REST. And as you can see down here, this is passing. Mm-hmm. And like if I did something silly, like if I changed this F to an A here, you'd see that the test would fail. So this is the thing that I've been trying to get done for the demo we've been trying to build, just not quite there yet, of creating an identity and then creating a data contract and then creating a document. So this is the create a data contract piece, part of that. And
we had AJ on a couple weeks ago where he demonstrated the creating the identity part. So we've got the creating identity part, although it wasn't automated. There were some manual steps involved when he was doing it, but the code was working. Now you've got the data contract working, because that was different. That was a different beast. Resulting, there's user data that's involved with that, where there's not user data that's involved with creating an identity alone. So now we've essentially proven the concept that the general approach that we're taking is sound, and there's light at the end of the tunnel. That's actually light that was brighter and sooner than I expected, because what you've done is you're not just doing this by hand. You're auto-generating a lot of this bin code directly from the Rust code base. So I was originally expecting us to start by doing a few of the state transitions manually, just by hand, and doing them one by one.
Which I did. I did one of them. I did one of them a few months ago.
We did the identity, and I was kind of expecting us to do the two other ones, but you, in your infinite wisdom, decided to take a step ahead and do the auto generation step before that. And now we know that not only can we craft some state transitions by hand, but we can also auto generate them, so that once we get n and n plus 1, we can do n plus any number of state transitions essentially through auto generation. And we can keep up with the Rust code base. No matter what changes they make, we can just run a script and auto generate the new state transitions directly from the source code, and create our bin code that's in JS. Mm-hmm. Now, I did want to take some time to step back again and say, from a non-technical standpoint, what is the whole purpose of this? I've stated it before, but it can't be stated enough, I feel like. It is important that when we have this platform product, right? We have this Dash platform product, and the whole value proposition behind this is to be able to give developers the ability to store data on a decentralized, what they would think of as just cloud storage, but what we know is technically on a blockchain with a network of nodes that are, running very differently than just typical cloud storage that you'd get with some kind of VC funded service provider. So, but at the end of the day, for developers, we need to have a comparable, if not better, user experience. Because if we think about it, what we're doing is we're asking developers to shift their paradigm from using a credit card to pay for cloud services, and all the things that are involved with that, using a credit card, and then using a payment provider like Stripe or whatever in their applications if they want to pass those costs down to their users. We're shifting the whole paradigm from that to, hey, how about we just skip the credit card companies and payment processor companies altogether, and then you can just pay for your data storage using magic internet money, aka Dash or cryptocurrency. And that's a big it's a big ask that we're asking already, just to have people meaning developers and users, shift to that paradigm of paying for the things, paying for their compute services with credit cards, to shifting that to paying with cryptocurrency. That's a big ask. So there needs to be a big benefit and very few hurdles to doing that. So right now, one of the big hurdles that we have is the developer experience is not only not better, it's just far worse in terms of the existing SDK. And so that's why we're trying to fix that. And what we have as a constraint is that the source of truth is the Rust code base. So that's why we've gone ahead and we're building all of the things that the Rust code base was supposed to do, but directly in JavaScript. And the whole purpose behind that is to maintain that performance that developers, front-end developers, expect out of an SDK. Very low size, footprint, very good developer experience, meaning that all the types are proper and working correctly, which was not the case with the existing JavaScript SDK. So yeah, that's kind of my spiel on the non-technical reasons that we're doing this. We've got a bit of an uphill battle with transitioning people from paying using credit cards to paying using cryptocurrency. Some people, like, I do envision that that's going to be the future. Digital payments is going to be the future, but getting them through that transition is not going to be easy. So we need to remove all the barriers possible. And yeah, the SDK needs to be as good, if not better, than the ones that they're currently used to using.
Yeah, I agree. Yeah, we want somebody to be able to develop an application, and they need to be an application developer. Those application developers, they're going to be really focused on the front end and what the user experience is going to be. We don't want them to also have to be a cryptography expert in order to bridge that gap. That's way too much to ask.
Right.
So yeah, I want to say that, like, in my mind, what I'm envisioning is, the application developer working on a front end, like some kind of like mobile app or web app, where there's a need to store data that is permanent and not really necessarily tied directly to the app, that could maybe bridge apps and stuff like that. And then on the other side is what I've been doing, which is the very low level bin code of, like, how do we actually talk to the Dash network with raw messages and do the signatures and stuff like that.
Mm-hmm.
And so, or maybe it'd be better to have this as like layers like this, like we have layers of abstraction where the bottom layers are very, very messy and complicated and require a lot of in-depth domain knowledge. But we can build on top of that with better SDKs and build a tower of abstractions to the point where maybe one day we can just say, hey, we have this new thing where you can store your data just like it's a local storage node, and it like automatically integrates with MetaMask or whatever hardware wallets that you're also using, and it just has like all the interface that you don't have to worry about. You can just say, where's my data? And then it'll say, here's your data. And then you can show your interface. And then if you want to change the data, you say, save the data. And then it just does it. You don't have to think about Dash. You don't have to worry about all the other underlying complexity.
Yep.
Yeah.
Yeah. And the only thing that people have to think about in terms of Dash is that's the payment mechanism, because it does cost money to pay. It costs money to store data on platform. However, that's up to the entrepreneurs to decide who's going to think about that part, whether it's going to be the users paying, pushing that cost onto the users and saying, oh, you want to store this object or whatever, you need to pay this, pay 50 cents worth of Dash. Like, you can present them a QR code or whatever. I don't think that that's going to be the winning strategy. If anything, it would be probably some kind of account top up or something, or even more ideally, or more likely, it's going to be the developers that are going to be paying. It's going to be the application developers that are going to be paying for the data storage on behalf of the users. And maybe they maybe they charge their users using traditional credit cards for a while until cryptocurrency becomes more mainstream. Who knows? However, but the main thing is still true. We need to be able to make that experience easy for both the developers and the users. I'm going to now go back to presenting my screen again, and hopefully this works this time without me getting super confused about what's on the screen and what's not. Is it showing up for you now, Matt?
Yes, it is.
I've shown this before. I'm going to show it again. This is our existing SDK, and there's just a lot of dependencies and a lot of it's a big mess. I consider it a supply chain security issue as well as a size, not just the size and speed of the SDK, but also with all these dependency comes supply chain attack vulnerabilities. So I'm not an expert on that by any means, but I do know the basic idea that, the fewer dependencies you have, the more contained that risk is. So I wanted to show that for one, but I also want to talk about the reality of the situation right now with our funding. So right now, currently, I like to show this every week, not just when my own proposal's in trouble, but whoever my guest is at the time, I typically show this screen to show what the current state of the proposals are. And as you can see, like, my proposal for 300 Dash is not passing at this time. And there are 37 hours left for voting. I'm sure the crowd node vote will be coming in soon that will make the situation even worse as far as the funding goes. Because this is essentially how I am able to pay you, Matt, to do what you're working on. AJ does have 200 Dash that is allocated to helping support this as well, but that's for AJ. And I think that there's enough work for him to do on his own. So I kind of need this funding to keep supporting your work. And like I've said in the past also, Matt, and everybody who's watching, my goal is to try to get people submitting their own proposals and becoming independent and not dependent on me as early as possible. So I'm hoping that I can get funded to remain, to keep funding you to keep working on this, but that next month or the following month or whenever, you'll be able to put in your own proposal for continuing working on this. But I also think that we're actually better off in terms of how much we need to allocate to this SDK than I expected. I thought that this first phase of SDK development was going to be more of proof of concept. And the first month from AJ's proposal didn't even pass. So really, he's only had 200 Dash from last month, and then hopefully 200 Dash for this month of funding. I didn't think that was going to get us as far as I think it's going to give us now. We may actually be able to even finish a good portion of the SDK. And let's make that distinction clear. Matt, we had a little bit of a pre-show conversation about what you're doing in terms of, like, are you building an SDK yet? You're not building an SDK yet. You're building the bin code and the type system that's auto-generated. So tell people a little bit more about that distinction and what may lay ahead in terms of SDK building on top of this foundation that you're building right now?
Yeah, absolutely. So I don't even envision a future user even seeing this bin code stuff.
Mm-hmm.
This stuff is very low level. It's in the weeds. There's a lot of things in these messages that have to rely on each other and have to be generated in a certain way in order to be correct. And requiring an end user to do all of that is just going to cause problems. They're going to end up with invalid contracts, or they're going to end up with somehow locking themselves in and not being able to fix something that they need to because something is broken or something like that. So this bin code stuff is like a low level and will not be, in my understanding, used by most people, but it will be used by the SDK developers, who are then going to wrap this up and say, okay, because I don't really want to think about nonces and which ID of the public key did you actually use to sign this particular one. You know, I don't want to care about that. That's not interesting to me.
Mm-hmm. As an application developer.
As an application developer, sure.
Yep.
What I care about is like, hey, I have a person, an identity, right? And I want to use this identity to store some data.
Mm-hmm.
That's all that I really care about. I want to create an identity. I want to have some, there's probably going to be lots of different ways. Create it from a given phrase, or like maybe create a remote identity that's being run on a hardware wallet, so you don't have direct access to the private keys and stuff like that. But somehow we create an identity, and then we say, all right, I want to make a message. I want to store a document. So here's the document. I want to store it with this identity. Go.
Yeah.
And so yeah, I don't remember what your original question was, but
I'll actually bridge it together right now, because my original question was the distinction between what you're building right now, what you're doing right now, and the actual SDK work. So
yeah,
right now you're not building an SDK, you're auto-generating the bin code data that creates the type system, so that TypeScript or JS doc or other editor tooling will be able to give developers the information that they need to work with the contracts and work with the state transitions. But there is still a step of creating that abstraction layer of an actual SDK that hides those low-level details. And that's work that's still in the future, but is closer than I expected it to be. I expect us to be able to nail a really good user experience and developer experience down within months, maybe a couple months after we get this initial groundwork done. And that's, I think that's going to be really good timing with the launch of Platform 2.0. I think that we'll be right there, ready for when Platform 2.0 lands. We'll have an SDK that's very workable. And I think that's going to be very good timing, assuming that we can maintain the funding, of course.
Right.
Now, a little bit more about the SDK stuff. So our SDK consists of not only this platform stuff, but also the work that AJ has done over the past years, actually, on the core side of things. And we had a conversation before where we were talking about who's going to handle what on that. You are more than capable of doing both of that, because you understand both of those things, platform and the core stuff, because you understand both the Rust and the JavaScript. And so you're going to be also digging into AJ's code bases for the core SDK stuff, understanding that and being able to take over that if and when AJ ever is not longer with us. And who knows when that's going to happen. I think he intends to put in proposals to continue funding that work. But we do need somebody that's able to work with both the platform side and the core side and understand all of the libraries that are involved with that. Mm-hmm. And you're the guy that is able to do that for us. So And we have AJ to thank for that, actually, because he's the one that found you, Matt. Even though I've probably rubbed shoulders with you here and there, being in Utah and being in the same building for the JavaScript meetups and whatnot, and the Rust meetups. But AJ is the one that found you, so that's great. Anything else to say? I saw that you have your screen up again. There's the documentation site that you've also been working on. Do you want to share that with us?
Yeah.
Okay. Let's see. That's still my screen. Before presenting a screen, remove the other meters. Okay. Yeah, they've changed some things up that makes me remove my screen first. So I don't have it available anymore. That's kind of a bad user experience. But anyway, what is this? What are you working on here?
Yeah, so I've talked a lot about auto-generating code from the Rust code base. So that auto-generated code is some JavaScript and a little bit of TypeScript definitions. But importantly, I also made sure to preserve any documentation comments that are part of the original Rust code and port them over onto the TypeScript so that it will come through in the editor and also in future API documentation. So this is like an example of this is some of the support bin code library for the generated code. But I decided to write some example documentation for how to start using this and to help guide people to what they actually need to use if they're looking at this documentation. So I don't personally even look at SDKs or anything if they don't have a decent documentation behind them. So with all the talk about wanting to have a good SDK for building Dash applications, we need to make sure that we can actually have something that is easy to read and easy to navigate. So this is I filled out this to show we can have, I'm going to, pending future funding, of course, but we'll make sure to have example code for how to actually use the different parts of the SDK. We'll make sure to have good descriptions and things like down here, hey, you might be looking at bin code, but if you really just want to do this, then you might actually just want to go look at these other functions, just to help guide people through. And then so the other thing I wanted to show here was that this is also including all of the generated bin code messages. So like the data contract create transition is the thing that I've been working with the most. So you can see all of this has been copied over from Rust, and I think the best example of documentation actually coming across is when you look at this distribution function and you look at exponential, for example. There's all of this stuff that comes right out of the Rust code base. It's basically markdown that gets translated over very nicely into this API documentation. So this is what I would like to continue to see as part of a decent Dash platform SDK. And one of the things I would also like to do is to fix up the types and add documentation for AJ's work with the different core libraries, and get all of those under one roof for an API documentation website to make this a lot easier to understand and navigate, because I personally have had a hard time understanding and navigating what I'm supposed to do with those. So definitely need to improve that.
Absolutely. And AJ does great job writing handwritten documentation on READMEs and things like that. But what you're talking about here is auto-generated documentation from the source of truth itself, which is the code. And yeah, because Rust is a strongly typed language, we get a lot of that for free. But the way that we've written the JavaScript code as well, we're using JavaScript with types, a JS doc, and so we should be able to auto-generate that as well, I would guess. But it's just one of those steps that we just need to do. Documentation is key. If developers can't approach this stuff and know where to look, we don't want people. We don't want people going around code bases. We want the code base to generate the markdown to be able to, show this stuff in an easier way, so that an average developer doesn't have to mess with that stuff. Even advanced developers don't want to mess with digging through a code base. They'd rather see the
They
code.
want to work on their own code, not somebody else's.
Exactly. Well, this looks awesome, Matt. You're doing amazing work. I hope we can continue it, and I think we'll leave it at that. That's pretty much all. Let me just check. It's pretty much all I wanted to talk about today. If you wanted to give us a little more of a high level description of what how you're doing the auto generation, I think that could be useful. But I don't know. Most of our viewers are probably not super into the technical side of things, but some of them are. So,
sure.
Can you give us a basic description of, like, you have a script written? I reviewed the code, so I kind of know what it's doing. But do you want to put that on the screen so that people can see how you're doing all this auto generation?
Sure. So I have a bin code generator here, and I will start with main just to go through what's going on. So it is walking through the dash core and the RSDPP and RS platform value packages in Rust. We go through those and we read them, and we use this awesome syn package, which is like short for syntax. This is actually used by Rust macros frequently. So anywhere, if at the top you see like the hash derive thing, like is used frequently in the Rust code base for the platform, for the Dash platform. Those derived macros and those other macros are often written using the syn package to parse the Rust code on the inside. So we're using this very highly well-used, very thoroughly tested library to parse the Rust files. So basically, we just scan through all the Rust files. We grab all the structs, all the enums, all the type aliases, all the documentation and attributes that come with those. And we just walk through them. There's a little bit of stuff here, like we don't want to just dump all the structs. There's too many, and a lot of them aren't helpful. So there's a few that we've specifically called out that I need, and then we have to do some munging because a few of them are like weird. There's the instant asset lock proof is actually like a special wrapper type that is not directly encoded. It's encoded as a raw instant lock proof, and so I have to do a little bit of hacks to fix it up. But once we do that, then we're doing some dependency stuff and blah, blah, blah. And then we write out the JavaScript and we write out the TypeScript.
Yeah. The file create is the key thing there. That's where you're actually creating JavaScript files from your Rust code, which imports the platform Rust codes.
Right. So, and it's kind of ugly. There's a bunch of TypeScript hacks that have to happen because I want things to come out of the JavaScript that JavaScript doesn't really want to do, and so it's a little bit of a trick to get it to work. But like, there's some stuff. I just had it here where like here we're translating all of the Rust types into their comparable JavaScript types. So. JavaScript numbers don't go up to 64-bit, and so we have those as big ints instead of just numbers and things like that.
A lot of people don't think that JavaScript has types, but you're saying that they do have types. They're just
this is TypeScript. So yeah, these are the TypeScript versions of things. Yes, JavaScript has types, not in the syntax, but the values have a type. Even if you can't like name it, you can't say that this is a type in the source code. Yeah, the values still have types. If you have a 0, that's a type number.
Yep.
If you have hello, that's type string. They still have the types. TypeScript just allows you to actually tell it what they are and then check that you did it right.
Right.
So yeah, and then we also spit out JavaScript, which looks a little bit different because this JavaScript that we're spitting out is not actually types. It is more of a description of how to bin code something.
Mm-hmm.
So the one that I would want to call out there is the not signable wrapper, where I was saying earlier that there are like the the data contract create transition. It has a signature at the end, but when we're trying to hash that message before signing the hash, we don't want to hash the like whatever signature crap happens to be in that memory location at that time, because whatever it is invalid and isn't relevant. So the way that the original Rust code does this is they wrote their entire whole wrapper around bin code. They call platform serialized and platform signable. But it's basically bin code with some extra customization capabilities in there. And one of the ways that it does this is it generates signable versions of all of their messages, and then it generates duplicated serialization code for all the signable versions of that to only spit out the fields of the structs that are not marked as was it skip for I forget what it's called exactly, but yeah, exclude from sig hash. Mm-hmm. And so what I do is anywhere I find that it says exclude from sig hash, I wrap it up in this not signable wrapper, which is just a little bit of JavaScript that says, hey, if we are currently in signable mode, skip this and don't try to encode or decode it. But if we're not in signable mode, then go ahead and pass it on to whatever is inside and go ahead and serialize that. And just to show an example of like what this looks like, let me see if I can pull this into a window. It's not going to let me. There we go. So if we look for the, and I can't type. So here is like, so this is one of the state transitions, for example, and you can see here that we have to provide the ID of the key that we used to sign it, as well as the actual signature here. But we only want to use those when we are not signing. So that's an example of where this is used, where it's transforming some of the Rust marker, like attribute markers, into different representations in JavaScript because we don't have attributes and stuff like that. Mm-hmm. So
very cool, very cool. And as you can see on the left side for the viewers, the generated bin code.js and the generated bin code.d.ts, that's kind of the product of all this, right?
Right. So the JavaScript is code that will be probably minified and compressed and shoveled off to the browser. So the size of this makes a lot of difference, but like there's a lot of comments in here. Like I said, that this comes right out of the Rust code base. So when it's minified, most of this will go away. This is logarithmic. This is the distributed function message, which has a lot of documentation. Mm-hmm. So yeah, this is what the browser will end up receiving is a minified version of this. And then see if it's going to be happy here. And then this is the TypeScript stuff that is used to generate the API documentation and also is used by your editor for figuring out what this is. So it's a bit messy. It's not really intended for direct human consumption. It's designed for machine consumption, and it's doing a pretty good job of that so far. But yeah, this will not be shoveled to the browser. This is all completely ignored by actual execution.
But it could be shipped to the browser. It just depends on what people want for their compiling options. Because I personally, I like it when I can view source and see exactly what's going on. I know that a lot of people don't, and most users will obviously not care, but some developers might like to see that. And it is a little bit of a more secure way to do things so that people can see what the code is actually doing. When it's minified, it's doing the same thing. But
can I show a quick? I want to show something. I have a clever little trick that I threw in to try to make debugging better, because I really have a personal passion for making a good debugging experience as well, if that's okay.
Yeah, let's do it.
So for not signable, for example, I'm just going to throw an error here. right? And then we're going to see that my tests fail. But I put a trick in here where I am creating method names dynamically to show you where this is coming from in the stack trace that you receive. So I actually had this where earlier I had some bug in my bin code, and what I got was this long stack of encode, and they don't have any useful, like, because they're all inside my wrappers. They're not actually going to show up in the JavaScript where you would like to see them. And so because that was difficult, I put a hack in here where let's see if I can. Yeah, so right here is where this is being generated, where we get to make a dynamic name for the function due to some JavaScript trickery that tells you what message it was trying to encode when this error was thrown. So
yeah, that's great. We talked about whether debugging was going to be easier through this method last week. We talked about that a little bit more, and I think we ended up with a little bit of a, who knows, maybe yes, but it sounds like you've made some effort to actually make the debugging experience great, which is really important, I think, for when dealing with new code, especially because there are a lot of bugs, and if the more that developers can help, the more that the end user developers can help the library developers by putting in a GitHub comment and saying, you know, here's the stack trace, and you can see that it's a little bit more understandable. That's, you know, that makes developing all the way through the stack a lot easier. So that's good.
Yeah.
Let's see. All right. Anything else that you wanted to share, or should we wrap it up?
Nope, I think I'm good.
Okay. Thanks again for all your work, Matt. You've done great work, and I'll just leave one last reminder. Please vote for the proposal, this one right here, as well as, you know, Ages is doing well, so I think that one's safe, but we definitely are not safe, and I am a little worried about this, because if I can't keep getting funding, then, you know, I can't keep working for Dash, and hopefully that's not the case. But yeah, thanks everybody for joining. Let us know if you have questions. And until next week, I think next week we'll be able to, you know, hopefully get to that point where we are demonstrating those three things, where we have the create identity, create data contract, and then create document against that data contract. And maybe you even write some abstractions, get a little bit of a start on the SDK, what that might look like, bringing all the things together, but with a limited API surface that's exposed. Something like that, I think, would be something that I'd like to demonstrate next week, or maybe the following week. So, yep, stay tuned for that. Bye, everybody.